Yeah, hello. My name is Nagapranav. I am a fourth year student in Mahindra University from a artificial intelligence. So the task is about chatting with multiple PDFs. So the template of output should be like the response from the LLM along with the source text, along with the source text from the PDFs that retriever used to generate the response. So as you can see, this is my code. And so let me start from the beginning. So these are the required libraries that I used in this code. So unstructured PDF loader to load the PDF. So unstructured PDF loader and Olama embeddings. So basically Olama is a website where you can access multiple models, like download multiple models like Hugging Face, and Chroma for database, and recursive character text splitter for splitting the text into chunks. So since the LLM models has a limited input size, so we split these input text to and convert them into word embeddings, and chart prompt template and prompt templates to uh, basically modify the input for LLM to understand, and the chart olama, which I didn't use actually, runnable pass through, and multi-query retriever, which is a kind of retriever where when we give a query, it using the LLM that we used, it generates the multiple text, it retrieves multiple text in different perspectives from the using those LLMs. And runnable sequence, which I didn't use. So those are extra. And here is the definite custom function to pre-process the PDF, inputted PDF. So basically we load using the unstructured PDF loader, and though using save it in data. Then using text recursive text splitter, we divide the entire PDF into chunks of 7500 with overlap of 100, so that when those chunks have the relation between each other. And I created a vector database using Chroma from documents using chunks, where Olama embeddings are used are embed text, which actually I downloaded previously in my laptop. So, and the LLM I used is Mistral AI, which is 4.9 GB, and created a retriever using the multi-query retriever dot from LLM. And LLM I used is Mistral, and query prompt, which I mentioned here. Basically it generates the multiple perspectives of the user question, and and it will return the retriever, this entire function. Then I created the Mistral using Chat Olama model, local model, so you can chat with the PDFs. And the template for the LLM is answer question based on the following. Given the context and question, it will retrieve the response. And this is a chat prompt template, which uses this template. And this is a run and highlight function where I customize this so that it outputs the source text from whichever the multiple perspectives that the LLM, that the retriever is using. It extracts those multiple source texts, and before it's putting into the LLM response. Basically, before it putting in the chain, lang chain. So the where in this function it has multiple retrievers, right? So basically, each PDF has one retriever. In iterating those retrievers, I created a chain where it inputs the retriever as a context and question as runnable pass through. Basically, these two are the inputs to the are the inputs we are considering. These two inputs are sent through prompt, and prompt is sent to LLM, and the output of the LLM is converted into string. That is basically the function of a chain in LangChain. Basically, it accumulates multiple models. So output of one model can be inputted to the other model. So this is the hierarchy of the entire model. So, and the response we will get from invoking that chain with query, input query. The input is equal to query, and we will retrieve the relevant docs based on, as I told you, multiple perspective questions are created based on the from the retriever using multi-query retriever. So those multiple questions extracts multiple source text. So those multiple source text are printed using are saved in the docs, and I printed with those docs and also printed the LLM response. So here is the PDF path I mentioned. One is attention.pdf, self-attention mechanism. The research paper, and the retrievers, I created a empty list and iterated the entire PDF path and created a retriever. And while through the query, like I inputted like what it takes an input query and I run the function run and highlight with query and retrievers as input. So these are the input parameters, query and retrievers, which uses in this function. And so when we run this, it will create an Olama embeddings for the PDF we are using, like attention.pdf, and it asks the input query, what is attention mechanism. After generating the question, it creates the multiple queries and create those embeddings. Then it retrieves the context and the LLM response. You can see the first context based on the first question it generated. So this is the context that is it's extracted from. And you can see so it even mentions the source attention.pdf. So multiple questions, multiple contexts are extracted, attention.pdf source along with the source. And at the end, we will see the LLM. It gives the LLM response, which is the generalized output after inputting in the Mistral AI. So you can see when we use this custom multi-query retriever, basically retriever uses some distance approaching methods like cosine similarity, distance similarity methods. So when we use this LLM, we could create a multiple perspectives based on the questions, and we could get multiple contexts out of the PDF, similar to what we are querying. So our output will be more accurate than using the retriever, which is based on distance similarity. So I used one is attention.pdf with the query, what is attention mechanism. It gave some very accurate answer. Model component primarily used in machine learning models for, in essence, attention allows the model to weigh and combine different parts of an input sequence when processing each position in the target sequence. So it gives the generalized output. And this is one other PDF I used is transformers.pdf, which is this PDF actually contains about the swing transformers. So basically I queried what are swing transformers. So it generated the multiple contexts, with it even extracted the GitHub's links, multiple contexts along with the source. And in the end, it generated the combined LLM response. You can see here, LLM response. Swing transformers refer to a type of vision transformer model introduced in the paper. Swing transformer, hierarchical vision transformer, uh, using shifted windows by the Microsoft Research Asia team. Twin transformers and a shift window approach, very accurate answer. Uh, and one other, so the above two methods are like when we input a single PDF. What about we input multiple PDFs? So when I input the multiple PDF, one is about the unsupervised approach to say video segmentation, and one other is GANs. And so basically I asked the question like, what is video segmentation? So basically, it iterates to the both the PDFs. So it created, as you can see, it created embeddings for the both the PDFs and also created multiple perspectives of the questions embeddings. So as you can see, it extracted the context from the segmentation PDF. You can see source equal to segmentation.pdf. If the context is in GANs, it also extract the context from the GANs as a source equal to GANs.pdf. As the context is only in the segmentation.pdf, it only extracted the segmentation PDF, and it created an LLM response, which is video segmentation is the process of identifying and extracting meaningful regions or objects from a video sequence. It involves analyzing temporal and spatial information to understand the dynamic scene. So so as you can see, the response is very quite accurate from what we know from the video segmentation. Uh, So this is the entire my PDF chart, which actually includes multiple PDFs, single PDFs, It also extract the context. It also understand the question in different perspectives using those LLMs, using multi-query retriever, uh, which actually increase. As you can see, Mistral AI is, you can call it as an SLM, which is actually very comparably less size than you can consider Llama or OpenAI. But so when we use this multi-query retriever, so our accuracy of the retriever, our chain LLM will increase drastically. So this is one of the method we could say to increase the accuracy of the LLM output. So this is my entire project. Uh, Thank you.